Hey, in this video I'm going to show you why when we multiply a series of ones together by a second series of ones that has the same number of digits, we end up getting this really cool pattern of ascending and descending numbers. So for example, in this one here, we have 1, 2, 3, 4, 3, 2, 1. So let's take a look at why that actually happens. As we go through this, remember that each of these numbers is the result of a series of operations that we did earlier. So when I explain it, just remember that this is actually the ones column, this is the tens column, this is the hundreds column, thousands, and so on. So when I'm explaining that, just remember that these correlate to individual positions within the final answer. So I want to know where this pattern is actually coming from. So what I'm going to do is I'm going to go through all of the steps that I would traditionally do with the multiplication that we learn in school, and I'm going to record all of the steps that I do because I'm looking for the pattern in the series here. So what I have over on the right side here is as I make an operation, I'm going to record with little dots every single step that I do. So the first step that we're going to do is we multiply 1 times 1, and we put the 1 down here. So for the ones column, I'm going to mark this number times this number, which correlates to this times this. Remember that these dots, we have 4 by 4. Each of these dots corresponds to one of these numbers here. So this position is this one here. This position is this one here. The second step that we do is then we multiply this times this. So then I record for the tens column this times this. Then we do it again, move 1 over, so then I mark for the hundreds this times this, and for the thousands this one times this one. Now once we get to the end, then as you know, we go below that and we add a 0 and we start again multiplying this times this, and we put a 1 at the bottom. When I record this, since I put the 0 there, that means that nothing is affecting the ones column anymore. Every step that I do from now on, if you remember from traditional multiplication, we're going to keep adding zeros every time we start a new row. So that means I can go ahead and skip down 1 because I'm no longer going to be affecting anything in the ones column. So that's why I jumped down and I started marking on this step here. And then the next thing that I did is I multiplied this times this, which corresponds to this times this. And then the next step, we did this one times this one, so we have this times this. And finally, this one times this one, so we mark this one times this one. So I'm going to go through them kind of quickly, and I just continue to mark them. Just remember, each time that we start with a new number, you go ahead and jump down to the next one and then continue on marking them. Okay, so go through all of these. And what you'll notice is starting to happen is as we go through all of them, it's actually creating a symmetric pattern. So this is a perfectly mirrored, once we have all of these here, it starts reflecting this. So this one reflects that one, and that one reflects that one. Now if we remember what each of these actually represents, we can really easily see where the pattern comes from. So for the first one, we have 1 times 1, which is going to be 1. For this one, we have 1 times 1 plus 1 times 1, which is going to be 2. Each of these is going to be 1 times 1 plus 1 times 1 plus 1 times 1. So for this one, we do that once. For this one, we do it twice. For this one, we do it 3 times. For this one, we do it 4 times. And then we start going back to 3, 2, 1. So this is where our pattern is actually coming from, is each of the operations that we do here. So knowing that pattern, we can see where our 1, 2, 3, 4, 3, 2, 1 comes from. And as it turns out, this pattern actually works with any series of ones multiplied by another series of ones that has the same number of digits. And there's another pattern that we can point out. So with the 4 ones times 4 ones, we had 1, 2, 3, 4, 3, 2, 1. If we have 5 ones times 5 ones, we have 1, 2, 3, 4, 5, 4, 3, 2, 1. If we have 6 ones times 6 ones, we have 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. So you'll notice there's a pattern going on. As it turns out, depending on the number of ones that we have, you simply count up to that number and then start going in reverse. So if we have 9 ones, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1, and on forever and ever and ever. And that pattern actually looks like this. As you can see, again, perfectly symmetric and easy to see how we end up with that pattern. Ta-da!